Greetings and welcome to the introduction to astronomy. In this lecture, we are going to be looking at the formation of the solar system and how we believe the solar system formed. And we will use this information later in the course when we look at exoplanets or planets and new solar systems we are finding outside of our own, and using that to help understand, even get a better knowledge of how a solar system in general forms. So we start out by looking for patterns. So how do we learn about things? Well, let's look at the patterns that we see, the patterns that are left over and remain today in our solar system. One thing we know is that all of the planets, every single one of them, orbit in approximately the same plane, meaning the solar system is flat. If you draw the solar system on a piece of paper, that's a pretty good estimate of what it is like. All of the planets orbit around the sun in the same direction. So if you're looking down from above with the sun, all of the planets go around the same direction counterclockwise. We don't have any that go clockwise. So they all orbit in the same direction. Most of the planets rotate on their axes in that same direction. If you look down from the North Pole of any planet, with a couple of exceptions, you will see that they are rotating in the same direction. And those two may be unusual things that we can try to explain. We also note that the planets are separated into terrestrial and Jovian type planets, as we looked at previously. And what about these many small bodies that we see in the solar system? What about the asteroids and the comets and other types of debris that we see? So what does this tell us? Well, what it means is what we believe is that the solar system formed from a large cloud of gas and dust, mostly hydrogen, just like everything else in the universe, that started collapsing about 5 billion years ago. The rotation of that cloud, you had a big blob of a cloud here rotating, and it had some slight rotation, very slow. Could have taken millions or billions of years to rotate once on its axis. But that slight rotation is reflected in the motions of the planets today. Had this been rotating the other way slightly, then everything would be orbiting in the opposite direction. We look at the hotter temperatures near the sun would have caused different types of materials to condense, specifically rock and metal. And then in the outer parts of the solar system, you would have the icy material condensing. And then finally, the small bodies, the asteroids and comets, are the leftover debris of planetary formation, and in fact regions where planets were unable to form. So let's look a little bit at how we go about building a planet. How do you build a planet? Well, what happens is that you start off with very small objects. As the nebula cools, the particles start to grow, and they collide and they coalesce into larger objects, grains of sand, pebbles, small rocks, larger rocks. And over millions of years, these continue to grow larger, becoming first what we call protoplanets just before they become a planet. And then as they gather enough material, becoming the planets that we see today. So here we see an artist's conception of what our solar system might have looked like in these early times, with a planet forming with a debris ring around it, and still our sun there in the distance with a lot of debris still around it. Our solar system at this point was a much messier place than it is today. So how do we get rid of that? How do we get rid of all of that extra debris? Well, this is the job of the planets and the sun. So what the planets do, they clean out the debris in their areas. Some of that debris becomes part of the planet, and some of it is ejected into interstellar space. So it will just be pass too close to a planet, gain enough energy to escape from the solar system, never to return. So that'll clear out some of the debris, at least the larger pieces. The sun is very good at about clearing out the remaining gas and dust. The solar wind and radiation pressure will clear out the extra gas and dust material, eliminating that from the solar system. So solar wind is an outflow of particles that will push against material. And the radiation pressure is the light from the sun, which will provide a pressure as well, again clearing out the very small debris. This will have no effect on any large objects, even things the size of a pebble will not be significantly affected by this kind of thing. But individual gas and dust particles will and will get pushed away by this and cleaned out of our solar system. Now, what is the evidence for this? Obviously, we cannot go back and look at what our solar system looked like 5 billion years ago as it was forming. However, we can look at other solar systems. And we see some of those. And this is an example of one. This is known as Beta Pictoris here. And this is the Hubble Space Telescope image. The star itself has been masked out. And we see a dust disk. So we can see dusty disks around other stars. We are observing that process of planet formation. We will never get to see it finish. It takes millions and millions of years for it to actually complete. But we can see different stages of it. And we have learned that there are now many planetary systems, that planetary systems are very common in the universe. And in fact, as of 2023, more than 5,000 planets outside our solar system have been detected. And if we think about it, just a few decades ago, we knew of none. So we have detected now over 5,000 confirmed planets outside of our own solar system. Now, we can also look for stars themselves. Can we actually see the planets themselves? And here we actually see over the course of a few years, running from 2009 to 2016, an image of looking at the star. Now again, the star has been masked out because otherwise it would overwhelm the brightness. So the star is actually buried down in here. But you can see each of these planets as they move orbiting around. So here's another one coming through, orbiting around the star. So we can see these different planets. So in very rare cases where they are close enough to us and easy enough to be seen. So this is the example of the star HR 8799. And we do see that as we can one case where we can actually view these planets outside of our solar system. So let's go ahead and finish up with our summary. And what we've looked at is the way we can understand patterns that exist in the solar system. We look for those patterns today, and they can help us understand how the solar system formed billions of years ago. We believe a large cloud of gas and dust collapsed that formed our solar system. And we can see evidence of the similar things occurring today around other stars. So that concludes this lecture on the formation of the solar system. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.